Good evening, everyone. So today we're here with Boyd Wilson, CEO of Omnibond Systems, LLC. And then
Omnibond for short.
Omnibond, just plain Omnibond. And the man behind the idea of Project Eureka, as well as some of the other products that we have at Omnibond as far as in bringing them in. So today we just want to ask you, where did the idea of Project Eureka come from?
So Project Eureka started out with a previous product. We had a product called CloudyCluster. Mm-hmm. CloudyCluster could run in AWS or Google Cloud. It's in respective marketplaces, and it allowed you to launch HPC resources. So you had a metascheduler that you launch a job to, and then it would automatically spin up compute nodes and allow you to launch your jobs, and then when it was all done, it would tear everything down. And as we talked to customers, a lot of people use that. A lot of people were very interested in that capability, but they said that they want that on-prem.
Right.
And so with that thought, we started architecting. We started saying, but we really like the metascheduler concept that CloudyCluster had. But, they needed to be rewritten to kind of accomplish this new thing. So we actually decided that, okay, we want to do this. But anyway, back to the story. We really wanted to, and those dynamic things are spinning up resources, tearing down resources, and you can't really do that in an HPC system that's really bare metal. And so we did a lot of research, looked around, and Kubernetes seemed to be the right place to do that. Mm-hmm. And with KubeVirt, with that you could do VMs and containers. So we thought, okay, so here's a platform people can run on-prem, and we still wanted the cloud capability, because we have a lot of people that said, well, we need to do the cloud, but not all the time, or we want to do it for this project, but not that project. So we really wanted this multi-cloud concept, all driven by a metascheduler. And so that metascheduler then allows you to launch nodes in either your Kubernetes environment that's on-prem, or to Google or AWS or Azure. And if you have a big existing HPC cluster, it will even be able to route jobs to that HPC cluster. The other part people spend a lot of time worrying about is data staging. Yeah. We actually spent a lot of time researching, looking for tools and things we could use in open source. We ended up writing our own OmniCopy that allows you to, as part of your job that's run by the Omni scheduler, there's a common theme there, that allows you to dynamically spin up resources, stage data, run jobs, stage data back, and tear down the resources. So really that complete life cycle. And that's really what we wanted to build. And we're now going into beta, and we've built it, and we'll keep adding the capabilities through the multiple beta cycles, and then by the end of the year, hopefully it's feature complete and maybe even released.
Now, I know personally, so you talked about CloudyCluster, the kind of beginnings of what Project Eureka has become. So I know I used CloudyCluster back in 2017. And I remember I got to see it from the side of a user hosting a hackathon. And from that side, CloudyCluster is really cool. It's this thing, you click the button, it spins up, and then you have an HPC cluster. Come from a world of setting up HPC clusters, it was a miracle in a box running on Google Cloud. With Project Eureka, there seems to be a different tone to it. CloudyCluster really seemed to be targeting the traditional HPC user, when Project Eureka seems like it's more for even an entry-level user or your researcher, wherein the tools themselves aren't a barrier to entry. Did you do that intentionally?
Some of it happened serendipitously, and some of it happened intentionally. We really wanted to make it so a whole enterprise, having lots of different projects, could have this project, this research group working in Google Cloud, this other group working on-prem in Kubernetes, this other one working in AWS. So we had these requirements. When you're in that project, you have specific applications, specific software, things you want to do. You launch, we have ClickOps where you can do interactive applications. And in the world of AI, you get the benefit of this can all be LLM driven. You can do LLMs, tie your code into that, have that part of these projects where you're running. You can train models, with the job, stage the data, train the model, bring it back. Also still doing your HPC simulations. So you really get the best of both worlds. And if you think about it, most AI training is done on Kubernetes.
Right.
So having this capability there native makes it a lot easier for your people that are used to that, who aren't traditional HPC users. So it's really expanding that base beyond that.
Right. And I mean, it also seems like when I say the barrier to entry, I like to call it that blinking cursor isn't your end-all be-all anymore. You have this pane of glass that you're sitting inside of a browser wherein, like you're saying, we can do click ops. We can say, I want to run X application. I want it with this many cores, and then go. And then outside of that, you also have the project side where you can bring in users and you can allow even the researchers to kind of manage their users.
Yeah, they can manage you basically have a project owner, can add the users they want, collaborate however they want, mount different data points on-prem. You can also access cloud resources. So you can, within your project, you can say, I want this Google bucket, I want this AWS bucket, I want this on-prem storage system on a normal scratch, and then it's all in that project associated. So you're able to then leverage it. And it's all tied, it's all known, it's all documented. And then another project will have different things. So it's really managing that complex layer down to a user level so people can just click and get their work done.
Right. Now, I also want to talk about what's really behind it, so that when you see Project Eureka, it speaks to you. You see the benefits of it. Being a former systems administrator, I immediately go, my users will love that. But behind it, there's a lot of technology, a lot of components and architecture. So I heard you say OmniScheduler and OmniCopy. I know there's a little bit of AFW tools in there. You talked about KubeVirt and Kubernetes, even though that's for the on-prem version. Could you talk a little bit about some of those different components that are built into it? And also, I know there's a piece in there for OrangeFS.
Yeah, exactly. One of the interesting abilities that we've actually had several people ask for CloudyCluster is the ability to dynamically spin up a Scratch file system. Dynamically spin up a Scratch file system. And with that, you can, and we leverage OrangeFS for that because it's upstream in the Linux kernel. We can dynamically easily spin it up. We're the maintainers, so we can actually fix any issues we find. But it's real interesting in this container world that if you have the kernel module, which is upstream, Linus pulled the latest things, last week, and you can load that module if it's in your kernel, it's part of it, but some distributions don't turn it on, so you have to turn it on, and then once it's running, any containers you run, you can natively mount a parallel file system, which is really rare, and you'll only do it because it's upstream in the kernel. And so when you're doing these workloads, you have full access to a powerful parallel file system from within your container. And that's where you can do your training, your inference, and so that all is there. We have AFW.tools is something we've kind of collaborated on over the past decade with some people at Clemson University, and it's really powerful. It allows you to provide an object interface to data and or APIs, and then you can wrap rules around it.
Right.
And so it's really this framework that you can build applications, and the OmniScheduler is actually built out of that. You could also have an eventing system. So some of the interesting things are when you submit jobs, it actually triggers events, and so the whole scheduler is event-driven. And it's not just your normal slog through a list or anything. So, and as states change, it actually triggers events. And there's even events that go to the compute nodes that actually trigger the things to set up and run and do those when they're launching. So it's actually a pretty unique and interesting architecture. And it's all open source. You can go to afw.tools to check it out.
And the same with, and like you said, with OrangeFS, that's also open source and built right into the Linux kernel.
Yeah.
So you have storage layer with OrangeFS. You have the AFW tools layer where it can actually trigger events. And then you also say you have OmniCopy. I'm assuming that OmniCopy then is able to do the data staging to kind of work through both AFW tools and OrangeFS. Is that true?
Yeah, so AFW.tools stores the objects and the object model for all of that, and it keeps the reference and also the key management. You know, you have to really worry about the key management and all this and make sure it's all secure and handle that. So but OmniCopy is very unique because we couldn't find anything that would do this. Mm-hmm. So we had to write it, but it allows you to do point-to-point data transfers from on-prem mounts, or to buckets, or to between buckets. So it's really this framework that allows you to do those point-to-point transfers. And you know, as the project rolls along and we go through Braidage, you'll be able to break up the workload, have different nodes do the transfer, dynamically spin up data transfer nodes, and all those types of things. So it gives a lot of flexibility, a lot of power.
So then that last block then would be the brains of the of the whole business. What causes the triggers? What fires off the OmniCopy to copy inside of inside of OrangeFS, as well as to fire out jobs. Then you have OmniScheduler.
Yep,
so could you just talk a little bit about OmniScheduler, because it feels like that's the meat of it.
Yeah, and we kind of talked about it earlier when we talked about AFW tools, how it does the event. So that's how the architecture works. But it really does wrap all this together, and it provides that authorization layer. So you can actually rapidly dump a ton of jobs into it. It's just entry rights into LMDB. That's the adaptive, you know, it basically takes the rights down to LMDB, where it actually does the stores and everything, which is the same database we use for the metadata in OrangeFS, very, very high performing. And so, but it's the logic, it's the brains. It goes through, you take your input script, you tell it what you want, where you want to run it, how you want to run it, and then you run it. And then it executes it. Now what's interesting is for the existing HPC places, let's say you have a Slurm cluster, we're actually going to write wrappers that allow you to translate, essentially launch a Slurm script straight into it. It'll translate to OCL, Omni Control Language, and then, you know, everything just works from there. So it's kind of seamless if you want to launch jobs. We're also allow on the other end to route. I have this HPC system. I want to submit a Slurm job. It can route all the way through and just goes to Slurm. So you can have some stuff go to the cloud, some stuff stay in Kubernetes, and some stuff go over there through a single interface.
So, wait. Okay, so let me make sure I say this right. I'm a grizzled, I'm not going to use the word old. I am a grizzled, experienced, wise researcher that has been in HPC since it was called Grid. That I am very accustomed to running my batch scripts. I made the transition over to Slurm, and I am used to that Slurm blinking cursor world. So you're telling me that inside of projectEUREKA, I can still drop to a terminal, send out my batch file, and depending upon how it's set up, it could either...
Based in the job script, you can describe how you want it to route.
So it could I could blast it out, I could run on local on-prem that's either a part of projectEUREKA itself or even another system on-prem.
Yeah.
Okay, that's crazy. All right, that makes sense. Well, with all of this, as soon as we start talking about other systems, then I have to, and you kind of hinted at it a little bit, I have to ask about security. It sounds like these are starting from the root of the OS, and they're going to have connections across everything. So that means that we need to worry about authentication. How does projectEUREKA deal with that?
Yeah, so there's two parts there, and you talk about security. One of the things we leverage is Open On Demand and the security model with per user Nginx processes that are all spawned and spun up. So everything that runs as a user runs as a user. So the only thing the user can do is what they're allowed to do. And there's JWTs or other pieces when everything they log in or access anything, it's as that user. So there's no thing in the middle that's trying to hold the rules back. So that helps with security, and that came from Open On Demand. And we use a lot of the app model that Open On Demand has. So when you get the interactive applications, you launch it, you have that capability. We kind of have it behind our user interface because we want that project base, that organization all tied within AFW, but you could also still go back and launch and have a lot of the capabilities of original open on demand if you wanted, so that UI is there if you wanted it, but you know, this all runs beside it to really give it that advanced project interface, the storage manager, and all those other pieces.
So then saying the storage manager, what that makes me think about, if everything I spin up as a user is owned by the user, I also know that we have a project interface. So that means that user is part of a group, it's part of a project group. If my project has access to certain S3 buckets, to certain other on-prem access, how does that user's job then, be it Jupyter Notebooks, VS Code, whatever, terminal, how do they then have access to the project data? Does it duplicate the data across, or what happens?
Yeah, no, I mean, it runs like a job. So it goes off and runs as a user, just like an HPC system, but it'll have access to the different resources through OmniCopy, so you can transfer the bucket. And when you start using OmniCopy, you gain the rights of the project. And so there's ways to kind of make things work. But ultimately, when the code's hitting the disk, it's running as that user, because you have all the old jobs have to still run, and that's how Linux works. So
POSIX. No.
Exactly. And so yeah, it's really cool. It pulls a lot of these pieces together, and in a world of AI, it's amazing. You can build these scripts that say, hey, I want to run 4 different data sets on this model. I want to see which data set works better, so I can do an A/B testing. Or maybe you want to run more than that. You can have a simple script that spins up the nodes, runs the training, and you can even have, when that's done, do your tests and see which one validates better. And the thing is to take these manual steps, and you're going to have to transfer models and do all these other things. And you used to have to write a whole bunch of script and copy and this and that. You don't get the optimization. You worry about permissions when you're copying between these things, and that all just kind of, we do all that behind the scenes now. And pretty cool.
So then I'm guessing it taking on the role of, again, of the technical lead at a company or at a university, how do I get my users in there? How's that going to happen?
Yeah, and that goes to the authentication part.
Right.
And we're enabling Eureka to be able to do, Google Authentication, any kind of, standard protocols authentication, but Google kind of come out of the box. We'll do Shibboleth and SAML with in common and the other federations around the world.
LDAP?
And LDAP.
All right.
And actually kind of the default installation uses a local LDAP if you don't want to federate. And that can obviously be pointed to an enterprise or campus LDAP as well.
So then in that, what that leads me to then, so that means we have authentication. We have the ability to run traditional HPC jobs with OmniScheduler. We're able to join all of our data sets together, be they either on-prem or in buckets or away. We can stage them and take care of that with OmniCopy and event-triggered events with AFW tools. All of our jobs and things are run with OmniScheduler. So then, with all this coming together, and the question is, when can we get it?
Yeah, and for the people that are willing to deal with a little bit of help and pain, we have the beta process that's just starting to ramp up. We're starting to deploy at our first beta site, and then so there'll be the beta process, and then we're targeting, in fourth quarter, we'll have RC candidates until it's baked enough to be done, but we'll be feature complete and people can test it, so people can join and try it along the way, and we'll help people, in this process.
So you're saying we'll help people. Do these beta potential users, are they going to need to pay for it? Or we of course, we said that the OrangeFS, a lot of the technologies are open source, OrangeFS, AFW. Is Project Eureka open source, or what's the funding model here? How's this going to work?
Yeah, so Project Eureka is not fully open source. It's built on open core technologies. And then what we do is always we're providing it free to the research and academic communities. They're non-commercially funded research, so they can use it. And now they can pay for support, or they can not pay for support. So they could come in and have us help set it up, get it going, and then they can run it. And they don't ever have to talk to us again if they want to do it themselves. That's our commitment to that community. And this is to get rapid adoption. We want lots of people using it.
Wow.
And then for commercial entities, now we hope that a percentage of those will pay for support or come in and loop through and do that. But for commercial entities, it is a full pay product. But most commercial entities want someone to say, okay, it's broken, fix it. So it's, they don't use free products very often. But we'll provide, competitive costs and provide them all this capability. We can also do things like help customize apps. Mm-hmm. You want to run a Llama LLM and have it deployed for different projects, and we can help with that and configure those things and get people set up. But get set up in a way that they can reproduce it. They don't have to call us the next time. It's like, okay, we know how to do this. Let's go. We're selling products and support. We're not selling consulting, but we do some of that to enable people.